CSIS.
No. Go.
Welcome to CSIS. We are the Sketchers. See, this is our 3D wax printout. And what I have here is my mini tutorial for logic gates, logic symbol gates. We have 3 gate types, and or not as applied to logic gate. So you see for AND gates, it's pretty simple. AND gates are pretty simple. You add the sum of your 2 inputs, so 1 and 0 is 1. For OR gates, it's either the inputs, so you have 1 and 0 is 1. Or if you have 1 and 1, it would also be 1. The only time you have 0 is if it's 0 and 0, which will give you 0 because there's no 1 in the inputs. Now for the NOT gates, if you have, say, 0 and 0, no, not 0, 0, sorry. If you have an input of 0, the output is going to be the opposite, so it's going to be 1. Or if you have an input in 1, the opposite is going to be 0, because it's not the input. That's the function of the NOT gate. Also, this is base 2, which is binary, so we only have 2 digits to work with, 0 and 1. That means you can't have any sum greater than 1. So let's say you have 1 and 1. That means you have to put 0 in carry, bring down to 1. That gives you an output of 1, 0 for whatever circuit you're working with. Now to the gate types. You have NOT gate and gate OR gate, like this. Function of the NOT gate, this is not the input as I explained before. Function of the AND gate is pretty simple, it's the sum of the inputs. Function of the OR gate, similar to the AND gate, except if you have 0 and 1, your output is 1. 1 and 1, your output will also be 1. The only time it's 0 is if your inputs are 0 and 0. And that's logic symbol tables and the gate types. Now my partner is going to explain
The binary conversion table. So what we did is we had the last numbers of the student IDs, which were 7 and 2. Then here we have the base. So we have the 2, 2, 2 to the 0 power to the first, to the second, to the third. And if you know multiplication, 2 to the 0 power is 1, 2 to the 1 is 2, 2 to the 2 is 4, and 2 to the 3 is 8. So what you do next is you see if these top 4 numbers, the 8, 4, 2, and 1, go into the last number of the student ID. So, for example, 8 doesn't go into 2 because it's bigger than, or 8 doesn't go into 7 because it's bigger than 2, bigger than 7. So you look at 4, which is smaller than 7. So you do 7 minus 4, which is 3. So you put a 1 here, and then you look at these numbers again. You see 2, which goes into 3, which 3 minus 2 is 1. So then you have the 1 and 1, and then 1 goes into 1, so you have a 1 here. Then you look at the second number of the student ID, which is 2, and you do the same exact thing. 4 and 8 don't go into 2 because they're bigger than 2, so you look at the next number, which is 2. 2 goes into 2 one time, so you have the 1 here, and then you look at number 1, and 1 does not, and then 1 goes into 2 as well. So this actually should be a 1 as well. So that's how you do the binary conversion. Or I'm sorry, no, I'm wrong. Once you have the 2, it becomes 2 minus 2, which is 0. So then 0 does not go into 1. So I was originally correct, and this is a 0. My bad. The truth table, you have the 0, 0, 0, 1, the 1, 0, and the 1, 1. So what you do is you're basically adding. So 0, 0 is a 0, 0, 1 is a 1, 1, 0 is this 1, and then the 1 and the 1 is a 0 with a carry 1. The reason is because there's no 2 in base 2 when you're adding the 1 and the 1. So what you do is you're subtracting the 2 minus 2 so that there will be a carry 1. So it looks like that. You have the 1 plus 1, you have the 0, and then you have the carry up here, which comes down. So it's not considered 10, it's considered 0 carry 1. And that is the truth table.